Hello everybody, we the Team 15 of K Division are here with our exploration course project. Our title is TIITRATIng board using Arduino board. Our team members are Saurabh, Vaidehi, myself Divyajyoti and Pratham. We are working through this project under the guidance of Sandeepar Kurundavade sir. Problem definition. Initially, to make any design of anything, we need to know the functions that product has to work on, and the main thing is the client's need. So keeping this all in our mind and with our sir guidance, we wrote this problem definition. This is the problem definition of our prototype. To make it better understand, the functions are being classified as equipment handling unit, indication unit and casing unit. The main thing is automatic titration board. So these have been classified into again the sub functions. So this is called the function tree. To make it better understand, we clustered these functions into subsystems so that we can work step by step. So this is the function tree and this is functional clustering. So according to the function clustering, the subsystems are beaker handling unit, burette handling unit and indication unit. So we are working step by step through this subsystem. So by seeing this, we can easily understand that the function that a prototype does. Now we are aware of problem definition and function tree and function clustering and all. So by this, with a deep research and study, each of us of our team designed these concepts. As you can see here, all the 4 members designed these designs. Design 1, Design 2 and Design 3 and Design 4. So after writing bug chart, problem definition and by seeing through the merits, demerits and all the aspects, under the sir guidance, we selected this concept. This defines the function we need and it is under all the constraints. Using bug chart, we got the highest rating from this concept, so we selected this design. When we see through this design, we can see actually we have 3 subsystems. So for burette handling, we need burette motion. So for burette motion, we have using pulley and thread. And the valve on and off, we are using servo motor. And for beaker shaking, we are using rotating platform to shake the beaker. These are the process in titration.
This is Vaidehi and the virtual implementation is as follows. So firstly, I would like to show you all the parts of our 3D model part by part. Then finally let me explain a little and show you the final 3D model. So here comes the platform of our 3D model. This is beaker, burette, clamp, pulley, filter ball, DC motor, stepper motor and stand. So now let me explain a little. So the DC motors are inclined in the opposite direction of a platform, which moves the platform in a clockwise direction, which helps in mixing of the solutions present in the beaker, which is kept at the top of the platform. And the platform shakes till the color of a solution present in a beaker changes. Next comes the beaker, which contains indicator and titrant, and the titrant from the burette is released drop by drop with the help of valve. The up and down movement of a burette is performed with the help of pulley, which is placed at the top. The valve of a burette is connected to a stepper motor, which helps in releasing the titrant drop by drop and it is performed till the color of a solution present in a beaker changes. The up and down movement of a burette is done by a pulley which is controlled by a DC motor which moves both in a clockwise and anti-clockwise direction. That is, while releasing the titrant, the burette is pushed inside the beaker, and after the completion of titration process, the burette is pulled up with the help of DC motor. The burette is clamped to the stand with the help of U-clamp. And this is how the process takes place. And this is our final 3D model.
Very warm greetings. This is Pratham. The slide will show you how our entire circuit diagram of our course project looks. The circuit diagram consists of an Arduino board, 3 DC motors, stepper, color sensor, and buzzer, also LED. The one single DC motor controls the motion of the burette. The 2 DC motor controls the shaking of the platform. The color sensor continuously reads the data of the color of the solution, and buzzer and LED acts as an output. This slide will give you the system flowchart of our entire system. Once the beaker is sensed, the burette moves to the beaker. Release of chemicals takes place, and followed by the shaking of the beaker. Once the color sensor matches the color of the solution with pink color, then LED will blink and buzzer will buzz. This indicates the end of our titration. If the color sensor does not match the color of the solution with pink color, then the process repeats from release of chemicals. You know what we are building in our course project. We need list of materials, its specifications, and the quantity. The part name listed are DC motor, stepper drive, nuts, bolts, structure base, microcontroller of Arduino Mega 2560, platform base made up of HD foam, pulley, beaker, stepper drive, power adapter, burette, tube, titrant. We also need some cutting tools like cutting, bending, drilling, milling. Motor sizing and battery sizing. Motor sizing determines the torque that is acting on DC motor, and also helps us selecting the type of DC motor, so as the battery. So first, calculating the torque of the DC motor. The torque of the DC motor comes out to be 2.45 for DC motor 1 and 1.47 for 2 and 3 DC motors. Now, battery sizing. Each DC motor consumes 0.3 ampere. Since we have 3 motors, it comes out to be 0.9, and Arduino also uses 0.1 ampere of current. The total 1 ampere current is used. Now, since our project is running for 3 hours, we need 3 ampere hour of battery size. Function specifications of our entire system. Holding the burette of 50 ml. Shifting the burette up and down. Dropping the chemicals via stepper motor. Shaking the beaker using 3 DC motors. Should sense a color change using the color sensor of TCS230. Should have provision to fill the burette. It should indicate the completion of the process. Since the process completion is indicated by the buzzer and LED, it should also indicate on and off of the machine.
Hi, I am Saurabh Kumar. I am here to explain the simulation of our prototype, that is TIITRATIng board. This is the following circuit diagram for our prototype, and this is the following code for our prototype. Step by step, I will make you understand the code and the simulation of our prototype. But before that, let's make you understand with the circuit connections. I have used one servo motor, 3 DC motors, 1 buzzer, 1 LED, and 3 switches. The switch 3 is used as an alternative for a color sensor because we don't have a color sensor in TIITRATING. So let's make you familiar with the circuit connections. The LED is connected to the pin A3, A4 and A5 of the Arduino board respectively as an output. The switches are connected to the pin number A1, A2 and A4 of the Arduino board respectively as an input. Servo motor is attached to the pin 5. DC motors are connected to the pin 6, 7, 8, 9 and A node of the Arduino board respectively as an output. The buzzer is connected to the pin 10 There are three variables declared x, y, and z. The x will store the analog signal from switch 1, y will store the analog signal from switch 2, and z will store the analog signal from switch 3. If switch is turned off, the analog input will be 0. If switch is turned on, analog input will be 1. As soon as we turn on the switch 1, the value of x will change from 0 to 1. There will be a red light and a big LED and a beep sound. As soon as you turn the switch 2, the value of y will turn from 0 to 1, and this DC motor will rotate anti-clockwise direction to bring the view rate close to the beaker. Servo motor will be turned 90 degrees, which will turn on the valve and raise the chemical drop by drop. These two DC motors rotate clockwise direction to shake the beaker and ensures that solution is dissolved nicely. As soon as we switch on the switch 3, which indicates that process is completed, the color of the solution is changed. Will make these two DC motors to stop. The servo motor to return back to the original position. This DC motor will rotate in clockwise direction to bring the view rate to its original position. Green light indicating process is completed, and a beep sound. So without delay, let's start the simulation. As you have seen, red light from LED and a beep sound. This part of our code has been run. As you can see, this part of our code is running. This DC motor is rotating in anti-clockwise direction to bring the view rate close to the beaker. This servo motor is rotated by 90 degrees, which ensures that valve is on, turn on, and the chemical release drop by drop. These two DC motors are rotated clockwise direction to shake the beaker well. As soon as I switch on the switch 3, this part of the code will run. Valve is closed. Give it back to the original position. Green light and a beep sound indicating the process is complete. So this is all from our side, T15. We have built a titration board which is cheap, reliable, and ensures that your work is done well. I hope you would like it. Thanks for watching this.